Hello, everyone, and welcome to this session where we are going to be doing some application building with Blazor. Now, I'm Steve Sanderson. I work at Microsoft. I'm on the .NET team. And the idea with this session is to get a little bit more advanced. So we're going to be digging quite deep into a lot of code in this session. And it's mainly intended for people who have some existing background with Blazor. Now, if you've never used Blazor before, there's going to be a lot of code and APIs that you might not recognize. So I'm not promising this is the best starting point for you. Hopefully you can follow along. But those people who have used Blazor before should have a good time. Now, we are going to use a mixture of .NET 7 new APIs and some of the existing APIs that you already know and love to build an audio browser application. Now, the idea with picking this audio browser scenario, it's really just to get you thinking about a different type of application, because I know we've all seen applications that read and write databases. Let's think about something a little bit different. And it doesn't really have to be audio. It could be any type of file. We're just using audio as an example. So consider this. Your user has got some files on their hard drive. Could be audio files, could be some other binary files. Maybe it's log files or some binary data generated by industrial machinery or something, who knows? And you are a developer of a web application and you want some way of working with these files. So you need to get that file data into your web UI so that you can read the data and maybe save changes to it. And you don't want to force the user to go through a process of uploading those files somewhere. That's quite inconvenient. You just want them to work with the file data right there on their hard drive. So that's what we're going to do with our Blazor application in this talk. So let's see how we're going to attack this challenge. I'm going to do this in 4 phases as we build up different parts of the application. And I will have to move quite quickly, so I won't show you every line of code, but I have put the code on GitHub and I'll give you a link to the full thing afterwards. So let's get started with trying to access files on the user's hard drive. So I've got a starting point here. Here's an audio browser application, which is Blazor WebAssembly. And I've got this also a Razor class library called Media Files API, where we're going to put some of the underlying API stuff in case we want to reuse it with other projects. Now, if I run that with a Control F5, you can see it's not really doing very much so far, it just prints hello world. And that is because I have created this using the new empty project template from .NET 7. So we only have one page in this application called index, and it's just going to say hello world. But I've also created this dependency injection service called media files, where we're going to add access to the user's file system. And that's coming from this Razor class library over here. And you can see it doesn't have much logic in it yet, but it does know how to load this JavaScript module. So why would we be doing that? Well, the APIs that we're going to use to access the user's file system come from the browser. It's a fairly recent spec. It's only a couple of years old, called filesystem. And this gives us some APIs in JavaScript that can access files. So we're going to do that here. And my real purpose is to show you some hints and tips for making your JavaScript interop code really nicely organized. So you can see we know how to load this media files.js file here. And that is coming from here. And that doesn't have very much in it yet. We're going to need to fill that out. And if you were looking closely, you might have been wondering, what is this JS module thing? Is that a framework feature? Well, it's actually not, although personally I think it probably should be, and I might start to argue that we should put this in .NET 8. But at the moment, it's just a general pattern. Don't worry about reading all this code. Obviously, there's too much. This is just a generalized system for being able to load a certain JavaScript module, for knowing how to release it when you're finished, and most importantly, for being able to make invocations into it. So it knows how to wait for the module to be loaded, and then when it is loaded, it can pass on an invocation. So don't worry about understanding that in detail, because it's a bit advanced. We are simply going to use it. So let's start by adding the ability to request access to the user's file system. And we'll do that using this show directory picker API. And we're going to return the name of the directory they've picked and an actual JavaScript object that represents it, so we can get the list of files later. Now, we don't want to work with JavaScript directly. We want to wrap that in a nice, strongly C-typed C# API. So here we go. I've got a method called show directory picker, which will return a JS directory. Now that doesn't exist yet, so we better define it. And you can see it needs to have a name and an instance on it. And we can do that really easily with a C# record type. And it's going to have name and instance. And I've also marked it as disposable because JS object references themselves are disposable. So we'll want to release that when we're finished. All right, so now we've done that and we've followed this simple pattern, we can use this inside our UI. So back in my UI, I am going to add a button. And when you click that button, we are going to try and open a directory. And we're going to have to fill in an implementation for that. And the implementation is going to ask the user to pick a directory using our DI service. And then we'll get the name and we'll display it on the screen. So let's see if this all works. When this reloads, we should hopefully see the button that we've just added there. That's a bit big. And when I click it, it should bring up the directory picker and I can pick a directory. I'm going to pick this particular folder that's got some audio files in it. And when I do that, the browser says, hey, user, do you want to let this web application access this directory on your hard drive? And we'll say yes. And then we'll get the name of the directory back in our .NET code. So that's a good start. But we don't actually just want to display the name of the directory. We want to show the actual files that are in it. So to do that, I'm going to follow the same pattern that I followed before by adding a bit of JavaScript code to wrap a certain JavaScript API. In this case, I'm adding a function called getFiles, and that's going to loop through all the entries in this directory. And for each one, it will return something with a name, a size, and a last modified date. And then I'll continue following my pattern to add a C# wrapper around it. So it's really easy to use. Right, so this is my getFiles async method, which is going to take a directory and return an array of JS files. And then we'll define JS file. And if you remember, it needs to have a name, a size, and a last modified date. So we'll just add a C# record that looks like that. Okay, then we can use that in our UI again. So I'm going to slightly amend this code now so that as well as doing what it did before, it now also tries to get the files from the directory. And then instead of displaying the name, I'm going to use a razor for each loop to print out the name and size of each entry in there. So let's just check that that's all going to work for us. I'm going to open my directory again. And this time when I do so, you'll see that it displays the names of the files and their sizes. All right, so that is pretty good. Now, what else can we do? Well, I want to improve a few aspects of this, and I don't have time to show you every step of the way. So I'm going to cheat a bit here by jumping forwards to a predefined state in my code here where I've added a little bit more functionality. I'll show you what it is. So let me just restart this and I'll show you what I've changed. Okay, so I've added an icon into this button. I've also added the ability when we pick a directory to show you the name of the directory and the number of files in it. And perhaps most importantly, I've added a feature where it remembers which directory you opened. So if I hit the reload button, you'll see it immediately goes back to that same directory. And I don't have to keep clicking that file browser, which would get pretty annoying. The way that works is that I've got this oninitialized async lifecycle method. And when this component is initialized, we'll call back into the browser to say, hey, if you opened a directory before, can you open the same one again? And we'll get the files out of it. Okay, so that is pretty straightforward. But I still want to improve the appearance of it in at least one more way, which is to do with the way that it looks while it's loading. This is a WebAssembly application, so hopefully it will load quickly, but depending on your user's network connection, they might have to wait a second or 10 seconds, it depends on the network. And while it's loading, what does it do? Well, it displays loading in black and white like that. It doesn't look very attractive. I don't even think it looks very professional, to be honest. So I want to show some tips for how we can make this look a little bit better. And my first tip is try and make your loading screen look like the same structure and style as the page when it has loaded. So in this case, we've got this kind of gray bar across the top, and I want that gray bar to show up while it's loading. So what renders that gray bar? Well, it's having a menu with a span inside it. That's what my CSS rule is looking for to render that gray bar. So I'm going to go to where my loading indicator is here in index.html, and I'm going to put in a menu with a span inside it, just the same. And then I'm going to put my loading messages in there. And let's close that correctly and get back to having the menu. And finally, we've now got back to some valid markup. All right. And once I've done that, eventually, there we go. I can come back to my browser and hit the reload button. And now you'll see the gray bar stays there while it's loading. I hope that state is showing up on the broadcast. But I think that looks quite a lot slicker. But we can do a bit better still, because if this application does take a few seconds to load, it'd be really nice to show an actual progress bar. And that's a feature that we've got baked in with Blazor WebAssembly and .NET 7, and it's super easy to use. I can do it without writing any code, actually. I just add some HTML. So as an example of how we can add a progress bar, we could do it like this. And this is literally the whole thing. I'm using Tailwind to set up a box that's got a certain height and a certain width. And then I've got another box inside it, which is a different color gray. And I'm saying the size of the box inside it is scaled according to the Blazor load percentage. And that's all we have to do. So now when I reload, so going a bit too quick, I'm going to have to slow down the loading so that you can see it. So I'm setting my network to be extra slow and clearing my cache. And now you can see that we've got a real loading progress bar that goes along as the site is loading. It's a nice subtle loading bar, which I think is better than having a big one in the middle of the screen, especially when it just sort of whips past really quickly in most cases. All right, good. So we've got access to local files. Let's move on a little bit by improving the functionality of the UI. We'll set up an actual grid with some sorting and searching because maybe the user needs to work with a larger amount of data than this. And this brings us to one of the .NET 7 preview features, which is a grid baked into the framework called Quick Grid. This is a preview level for .NET 7. So we'd love your feedback about that. And it's pretty easy to use. All we have to do is go to somewhere where we were doing a for each loop before. We'll get rid of that. And I'm going to drop in Quick Grid instead. So Quick Grid is complaining at me initially. The reason it's complaining and why we've got this red squiggle here is because it wants a queryable of T to display so that it can dynamically change pages and sort order and things. And I haven't given it that. I've just given it an array. And it won't be happy with that. So I'm going to change it to a queryable of JS file like that, just to show we're not limited to doing querying over database content. We can also do it on in-memory data as well. So I can turn an arbitrary array into a queryable using this asQueryable extension method like that. Okay, and now our grid is going to be happy that it can work with that data. So when I save that, it should compile properly this time. And if I switch back, my UI becomes blank because, well, my grid doesn't have any columns yet. Let's put some columns in there, shall we? We'll start quite simply with these 3 columns for name, size, and last modified, and I'll mark them as sortable. And hopefully that's all we have to do to get an initial UI that starts to look quite nice. And we've got multiple columns, we've got sorting, that's all good. But some aspects of the way it appears don't look so great. I really don't like the way this size has been formatted. I don't really even know how the user is supposed to understand this number. I want to show a value in megabytes or kilobytes or something like that. And I can do that very easily just by pulling in a third-party NuGet package that deals with that kind of format for me. So I've changed this property column now to use this third-party library called PrettySize, and that is going to render the size in a more recognizable format. So now you can see it displays a number of megabytes or kilobytes, and that is a lot better. Okay, cool. Right, so remember I also said I wanted to have a search feature, and that's quite important because maybe the user doesn't just have 4 files, maybe they've got a lot more. So in this directory over here, I've got 1,200 files. It's quite a lot. You can't really expect the user to manually search through this list. You'd want to have a search feature. This, by the way, is a load of samples of humans speaking, which comes from the Mozilla Common Voice dataset, which is a really nice one. So thanks to Mozilla for that. And to add searching, I'm not going to go through this step by step. I did do that in a talk yesterday, so you can go and see it if you want to. But I'm just going to show you the finished code for doing searching. It's not too difficult, but we've got limited time and I want to show you more stuff. So here's what we've got now. You see we've got this little search icon, and when I click on that, a box shows up and I can start typing stuff. And on every keystroke, it's updating to produce the search results. And of course, I can still do things like sorting within that. Okay, so how does that work? Well, what happens is I've got a field to keep track of what the user is searching for here, called search name. I've got a text box, which is bound to that field, and I'm using a new .NET 7 binding feature called bind after to say each time this binding updates, we want to update the filter. And what I'm doing is I'm simply adding a where clause onto my queryable there. So that's all it takes to do that. Pretty straightforward. All right, good. Let's move on. Let's think about rendering some previews of the audio data. I want to render actual graphical waveforms, but it's going to take us a few steps to get to that. Let's start moving in that direction. Firstly, where is this preview going to appear? Well, I'm going to add a new template column into my grid here with a title of preview. And I could start putting all my UI logic in here, but it could get a bit complicated. So let's factor out a separate component, and I'm going to call it audio preview, like that. All right, now I haven't defined that just yet. So the code editor will offer me the option to create a component from this unknown tag. So I'll click on that, and you'll see that's added a file for me now, which is initially blank, and I'm going to drop in a bit of initial content. So my initial content here says the audio preview will have a parameter called file, which will be an actual JS file object, and this is going to be required. And we'll add some real logic here in a minute, but for now, it just displays to do and the name of the file to check that we've wired it up. And if I go back here, you'll see that the editor is complaining at me saying you're supposed to pass a file and you haven't done that, so I'll do it. And what we'll pass is whatever file is the current grid row, and that's called context in this case. So with all that in place, if I come back here now, you'll see it's now rendering this preview component, which says to do, and then the name of the file that we should render a preview for. Okay, so how do we render a waveform? Well, the first step is going to be getting the actual audio data out of the file. And that could be a bit tricky because we could have multiple different types of files. For example, back in this other folder over here, you can see I've got some MP3s and I've got some WAV files, and there could be other types of files as well. So how are we going to decode all these different types of files? Well, you could start using multiple different libraries to handle different file types. And I actually did start doing that when I first was preparing this, and it was working okay. But then I had a bit of a brainwave, which is we're running inside a browser here, and the browser already knows how to parse a wide range of audio files. So can't we just get the browser to do this for us? And the answer is yeah, it's actually quite straightforward. What we can do is we can use some APIs that are built into the browser like this. So I've added this in the background sneakily. You didn't see me, but I did. And what this does is it goes through a slightly awkward process to get access to the raw bytes from the file. And once it's done that, it can decode the audio data from it. And we'll pass that efficiently back to .NET through binary interop. And then we can access that through our DI service in .NET. So let's do it, shall we? I'm going to drop in a bit of logic that says when this preview component is created, we'll decode the audio file. And just to get started with, we'll figure out how many bytes we get back when we've decoded it. And I'm just going to render that to the UI right now. So let's render this message. All right, let's check if this works and we're able to successfully decode files. And the answer is yes, we can. So in the case of something like a WAV file, you'll notice that the decoded size is pretty much the same size as the file on disk because it's not compressed. Whereas for an MP3, the decoded size is far bigger than the file on disk. So that makes sense because MP3s are very compressed. Okay, now we don't just want to get the decoded bytes from the file. We actually want to render a waveform from it. How will we do that? Well, we could start rendering it using something like Canvas APIs, or we could use Skier or some other bitmap renderer like that. But there is potentially an even easier way to do it, which is using SVGs in the browser. Blazor has for a while had the ability to generate SVGs dynamically, and it's a really powerful and quite easy technique. To be honest, I think it's a bit underutilized, so I'm trying to market this idea a little bit because it's a very powerful and useful thing to do. So how could we generate an SVG of a waveform? Well, let's build up towards it. I'm going to give you an example of an SVG. Don't worry about understanding this weird goop right now. Let's just see what that renders. Okay, you'll see it renders 3 vertical lines. Well, why does it do that? Well, it's what this path says. So this first instruction here says, move to 10 across 0 down, and then draw a vertical line down from there. And then move again, draw another vertical line, move again, do another vertical line. So that's 3 vertical lines. So we can use that to render a waveform. We just have to generate a big string like this that encodes all the lines in the waveform. And I've written a little bit of C# to do that. It's a bit too much code to go through step by step, so don't worry about understanding it in great detail. I'm just going to show you, I'll just quickly sort of mention a few of the details about how it works. So we're receiving the raw byte data. We're reinterpreting it as a set of floats because that's what it actually is. Then I'm setting up a couple of string builders, one for the top half of the graph and one for the bottom half, because I want them to be in different colors. And then we're looping across the image horizontally. And for each column in the image, we're finding the highest and lowest audio sample in that part of the file, and then appending some SVG path instructions. Okay, so that's the whole thing. Don't worry about it if it wasn't completely clear, but we're going to use that now. So I'll add a waveform SVG field right here, and I'm going to populate it by saying the SVG equals generate waveform SVG from the data that we've decoded. And then finally, I can render that into my UI, just like this, with the top path and the bottom path in a slightly different color. So let's try that out, shall we? I'm going to restart my application, and now you'll see it actually does display real waveforms. So that's pretty good. Let's just check it works if I move to a different set of files as well to make sure everything's really happy. And it seems like it is working. Okay, great. So we are doing well. Right, the last thing to think about is performance. So we're probably feeling pretty good about ourselves as developers right now because we've got everything working, but does it really perform well? And I'm sorry to break it to you, but bad news, there are some scenarios where this is going to behave quite badly indeed, because we have been a little bit naive in some of our implementation decisions. So let me show you one of the ways that this is going to go wrong. Let's start with if you've got a big directory with lots of files in it. I'm going to reload this directory, and then I'm going to try and scroll down to the bottom really quickly. And my UI is really laggy. I don't know if you can see, but that gray box is following ages behind my mouse, and it's kind of all locked up. And where are the waveforms? This does not seem to be working well at all. So what's going on? Well, eventually it shows up. But what's going on here is that we have very stupidly decided that we're going to when a directory is open, we'll load every single file in it into memory, and we'll decode every single file, and we'll render a waveform for every single file, no matter how many of them there are or how big they are. And that doesn't really make sense. We would ideally only load and generate previews for the things that are actually on the screen. And the good news is it's very easy to do that. We can go back to the grid, and we can tell it to enable virtualization. And that means that it will only render the stuff that's on the current screen. So we'll only instantiate audio previews for stuff that's on the screen. So we'll only load and render stuff that's on the screen. You get the idea, okay? So let's try this now and see if it's a little bit better with the large directory. So now when I scroll to another point, you'll see it immediately just generates the previews for whatever matches my current scroll position. So that is clearly far better. Okay, so again, we might think that we've finished now and we've solved all the problems, but there could still be another issue. And to illustrate that, I'm going to jump forwards in the implementation one last time to a place now where I've got the ability to track some timings of what's going on. So let me show you what I've just changed there. Let's get this going. All right, so firstly, I've added a play button. I don't know if you can hear it. You might not hear it, but it was playing out of my speakers just then. That's good. But I've also added this little timing information here where it says 4 milliseconds. And I've set it up so that every time I click this waveform, it will re-render it and measure how much time it took to do so. And you can see it takes, like 3, 4, 5 milliseconds or something to render. And you might think, okay, that's fine. That's fast enough, isn't it? But what if these files were much bigger and we had a lot more audio samples to walk through? So over here, I've got another directory now with some full-length songs. So these are multi-megabyte files. They've got many millions of audio samples in each file. Here's a whole song. Don't know if you can hear that, but there you go. And how long does it take to render these waveforms? Well, if I click this a few times, you can see it's taking in the realms of about 40-ish milliseconds. And again, you might think that's okay, but what if the files were bigger still? Or what if the user was working on a low-end mobile device, which had a much slower CPU? Maybe it would actually be quite laggy. So to make things faster still, the big technique that we've got for Blazor WebAssembly is ahead of time compilation. That's not new in 7. That was already part of the 6.0 release. But one of the great things in .NET 7 is that the runtime team added a lot more optimization for the way that the AOT code generation process works. So it can produce significantly faster code. I don't have exact numbers, but I've seen micro benchmarks that have been around 50% faster or even faster still than that. So I'm not promising anything specific for your app, but let's see what happens when we AOT compile this one. So I've actually already AOT compiled this and published it. And I'm going to start this up from a static file server here. This is the same application code that you just saw us work on there. And I'm going to open the same big files directory here. And we should see that runs rather a lot faster. So the same big file that was taking 40 milliseconds before is now taking in the realms of 2, 3, 4 milliseconds. So that is something between 15 or 20, well, 10 to 20 times faster than we had it running before. So that is a big improvement indeed. Okay, so we've done a lot of app building. We've made the performance good. We feel pretty happy. I just want to throw in one last bonus for you. Bearing in mind that this application is implemented in WebAssembly, running in the browser, and it's just working with files that are local on the user's hard drive, that means it's absolutely trivial to turn this into an offline capable PWA. Again, it's not a new feature, something that's been in Blazor since the beginning, but it works really nicely in this case. So let's just see that happening. So I've got this AOT compiled application. I'm going to click on the install button here. That's going to now pop up in its own separate window. I'll let Windows pin it to the taskbar. And that means that this user now has on their application taskbar the icon for this application. They can click that and it pops up in its own window separately from the browser, and they can now do all the same things that you saw us do before. And so effectively, they've got something that looks, something that feels like a native desktop application. It works offline, and it performs really well thanks to the AOT compilation for working with their local files. All right, so there we go. That's all we're going to have time for in this session today. If you want to get more information about this, you can get the code for the finished application from the GitHub repo that I've given you a link to at the bottom there. And if you want to learn more general stuff about Blazor in .NET 7 or all of ASP.NET Core in .NET 7, you can use the link at the top there, and that takes you to a blog post that's got tons of extra content. So there we go. I hope that's been useful. If you've got any questions, you can ask them right now, or you can contact me through Twitter, or you can contact the whole Blazor engineering team through our GitHub repo. But that's the end of me for now, and I'm going to hand back to Richard in the studio. Thank you.